Let's look at an example of a calculation involving Boyle's law. To start, we'll go over the meaning of STP and SATP. STP stands for standard temperature and pressure, and it's referring to a point where the temperature is 0 degrees Celsius and the pressure is at 1 atmosphere. Recalling that 1 atmosphere is equal to 760 millimeters of mercury, which is also equal to 101.325 kilopascals. When we see SATP, standard atmospheric temperature and pressure, that's referring to 25 degrees Celsius and 1 atmosphere. We'll need this information for this question. In this example, we have a gas occupying 2.7 liters at standard temperature and 150 kPa, or kilopascals. We want to know what its volume is at STP. So we are changing the pressure from 150 kilopascals to standard pressure, which is 1 atmosphere. And we want to know the new volume. The initial temperature was 0 degrees Celsius. So what that means is that Boyle's law applies because my temperature is being held constant. My T1 and my T2 are both 0 degrees Celsius. Boyle's law is P1V1 equals P2V2. If I make a list of the variables from the question, my initial volume is 2.7 liters. My initial pressure is 150 kilopascals. My final pressure is 101.3 kilopascals. And you'll notice that I needed to change the unit. I talked about having 1 atmosphere, which is equal to 101.325 kilopascals. We need, when we're solving this kind of a problem, we need for our pressure units to match. This will also mean that my volume units will match. So when I plug into Boyle's law, 150 is equal to 2.7, and then I'm going to divide by 101.3 to solve for V2. That 4 liters that I find, the unit is liters because the initial volume was measured in liters. So some key things when you're using Boyle's law, you need the temperature to remain constant. And when you're plugging into the relationship, you need to make sure that your pressure units match each other and your volume units match each other. That might mean that you need to do a unit conversion before you can do your solution.